So in this lesson, we're going to do transformations on our rational functions. The transformations remain the same. Remember, A is either our reflection over the x-axis. That was our roxa. It can also be a vertical stretch or a vertical compression. B is still the same. You must factor out your B. B would be a horizontal reflection, a reflection over the y-axis. Or it would be a horizontal compression, a horizontal stretch. And remember, that's opposite. So if it's at 2, it's a compression by a half. If it's a 1/3, it's a stretch by 3. So remember, those are still opposites. Your C value is still negative C goes to the right, positive C goes to the left. And then your D value is still your up and down. Plus D goes up, a negative D goes down. So none of that has changed, but this is what they're going to look like. So graph the following, state the transformations in order, and give the vertical and horizontal asymptotes. So here we go. So if I look here, remember first come reflections. I see a reflection over the x-axis, so write that, roxa. And then are there any dilations? I see a 2, so that's a vertical stretch by 2. And then my translations, which x minus 3 is to the right 3 spaces. So those are the transformations that are happening. My parent function table, this is rational odd. So -1, -1, 1, 1. And the third blank here is to give my parent function asymptotes. That was x equals 0, y equals 0. So let's write our transform table. So the only horizontal that happened was going right 3 spaces, so that's x plus 3. My verticals were a reflection over the x-axis and a stretch by 2. Now, because we moved to the right 3 spaces, my new asymptote is going to be x equals 3. I did not move up or down, so my horizontal asymptote is still y equals 0. All right, so we take each point and transform it. -1 plus 3, and then 1 plus 3. -2 times -1, and then -2 times 1. Horizontal asymptote was x equals 0, or x equals 3. I just did that backwards. Horizontal is y equals 0, vertical is x equals 3. So for domain, you can write it using interval notation, which would be -infinity to 3, union with 3 to infinity. Or the shortcut would be just saying all real numbers, x is not 3. Your range would go the same way with y equals 0. You could say -infinity to 0, union 0, infinity, or the shortcut would be all real numbers, but y is not equal to 0. There, now you can see what I wrote. So the graph for this, I'm going to put an asymptote at x equals 3. That's my vertical asymptote, goes through the x-axis at 3. My horizontal goes through the y-axis at 0. And if I just plot my 2 points, I've got 2, 2, and 4, -2. And I know the basic shape is that L shape that approaches but never touches my asymptotes. And it doesn't curve in, it goes towards the asymptote lines. So it looks something like that. Not perfection, but something like that. All right, let's try another one. Number 2. My parent function table would be -1, -1, 1, 1. And my parent function asymptotes are x equals 0 and y equals 0. My transformations, there are no reflections. There are no compressions or stretches. Those are dilations. But it does move to the left 2 and down 4. So that's going to affect everything. So if I go to the left 2, that's x minus 2. If I moved down 4, that's y minus 4. My asymptote lines just moved left 2 and down 4. So my horizontal asymptote, which is my y, is going to be at y equals negative 4. Because it was at 0 and now it moved down 4 spaces. So 1, 2, 3, 4. My vertical asymptote, which is the x equals, because it moved to the left 2 spaces, it's going to be x equals negative 2. And sometimes you have to turn your paper to get a good line. All right, let's plot some points. Negative 1 minus 2, positive 1 minus 2. Negative 1 minus 4, positive 1 minus 4. And we've already talked about the asymptotes. That's y equals negative 4. So if I plot these points, negative 3, 1, 2, 3, negative 5, and then negative 1, negative 3. So all we have to do is make that L shape, make each branch the best you can. It approaches but never touches. So my domain, I'm going to take the shortcut. Domain comes from the vertical. All real numbers, x cannot be negative 2. The range comes from the y values. All real numbers, y cannot be negative 4. And that would be the graph. All right, we're going to do the same thing, but now with a couple of rational even functions that have an x squared on the denominator. So the same rules still apply, but this time our parent function table is negative 1, positive 1. And my asymptotes are still x equals 0, y equals 0. Let's look at the transformations. That negative is a reflection over the x-axis. That's a horizontal change. And that x minus 2 moves it to the right 2. That's a horizontal change. So here we go. If I move to the right 2, that's an x plus 2. And the only thing I did vertically was I reflected over the x-axis. So that's negative y. So negative 1 plus 2 is 1. And then 1 plus 2 is 3. And for both of those, I get negative 1 for my y value. So my horizontal asymptote, remember that comes from your y. It did not go up or down, so it stayed at y equals 0. Your vertical asymptote comes from your x. It moved to the right 2, so that's x equals 2. So horizontal y equals 0, vertical x equals 2. So we'll graph those asymptote lines first. Then we'll graph these points. 1, negative 1, 3, negative 1. So notice we've reflected over the x-axis. And now you do your best to draw that little L shape that approaches your asymptote but does not actually touch it. So my domain comes from my x's. All real numbers, but x cannot be 2. My range comes from my y's. All real numbers, but y cannot be 0. All right, number 4. So this one, it looks like we have a vertical stretch of 2. And there's no reflections. X plus 4 moves it to the to the left 4. And the minus 3 goes down 3. So again, your parent function for rational even is negative 1, 1, 1, 1. And my asymptotes are x equals 0, y equals 0. So if I move to the left 4, I'm going to write x minus 4. And I did a vertical stretch by 2. So that's 2y minus 3. And now we get our coordinates. Negative 1 minus 4, positive 1 minus 4. 2 times 1 minus 3 for both of those. Now my vertical asymptote, because I moved to the left 4 spaces, is going to be x equals negative 4. My horizontal asymptote, because I moved down 3 spaces, is going to be y equals negative 3. And we're going to place those on our graph. Let's see, 1, 2, 3, 4. And then we plot our points. Negative 5, negative 1. Negative 3, negative 1. And then we draw our L shapes that approach but never actually touch the asymptote lines. Domain, all real numbers, but x can't be negative 4. Your range, all real numbers, but y is not allowed to be negative 3. We have one more set of examples. There's an rational odd and a rational even. So let's take a look here. Before we start to list our transformations, notice it's rational odd. So that was negative 1, negative 1, positive 1, positive 1. Now, if we start talking about transformations, I see a reflection over the x-axis, and I see a vertical stretch by 2. Look at the denominator. This is what catches us every time. We can't talk about these transformations until we factor out the b value. Our b value is positive 3, which means a horizontal compression by 1/3. Be careful there. And then the x minus 1 means it's going to the right 1. The plus 4 means it's going up 4. So we've got a lot going on with our transformations here. So for the x values, I did a compression of 1/3, 1/3 x plus 1, because I went to the right one. My y values, negative 2y plus 4. So we'll deal with these little fractions here. 1/3 times negative 1. Negative 1/3 plus 1 is 2/3. Positive 1/3 plus 1 is 1 1/3. And my asymptote, since I went to the right 1 space, my asymptote went to the right 1 space also. My y values, negative 2 times negative 1 is positive 2 plus 4. And then negative 2 times 1 is negative 2 plus 4. Since my y value went up 4 spaces, so did my asymptote. So I've got x equals 1 for my vertical and y equals 4 for my horizontal. And put those up here. And x equals 1. Now these fractions, we're going to have to just do our best to get them in the right places. 2/3, 6. So over here, and I'm going to go up 1, 2, 3, 4, 5, 6. Right about there. 1 1/3, just on the other side, but up 2. So the larger our vertical stretch, the further away we are from that intersection point. And again, we just draw our 2 branches the best we can, approaching, but never touching the asymptote line. Remember, domain comes from your x values. It's everything except the vertical asymptote. Your range is everything except your horizontal asymptote. Next step, we have a rational even. I don't see any reflections, but I do see a vertical stretch by 3. Now in our denominator, notice there is a b value in there that we're going to have to factor out. So our b value is 2, which means it's a horizontal compression by a half. Remember, b value is opposite the end. The x minus 2 tells me to go to the right 2 spaces, and the plus 1 tells me to go up 1 space. Let's fill in our table. Negative 1, 1, 1, 1. The asymptotes are the same regardless of odd or even. But notice in an even function, my y values were both positive. All right, so let's do our transformations here. It's 1/2 x plus 2. And for my y's, it's 3y plus 1. Let's plug our numbers in. 1/2 times negative 1. So negative 1/2 plus 2 is 1.5. Positive 1/2 plus 2 is 2.5. For my y values, I plug in 1. 3 times 1 plus 1. So those are both 4. So for my asymptotes, if I went to the right 2 spaces, my vertical asymptote also moved to the right. If I moved up 1 space, my horizontal asymptote also moved up 1 space. There it is. And x equals 2. So we can put those in our answer blanks. And we plot the point 1.5, 4. 1, 2, 3, 4. And the same for 2.5, also 4. So remember, rational, even, they're both on the same side of the horizontal. They're either both up or both down. Domain, all real numbers except for the asymptote line. The range, all real numbers except for the horizontal asymptote line. And that's how we transform rational, even, and odd functions.